Welcome to this channel. Welcome to my class once again, people. Today we are going to continue our agenda and solve question 4 of the maths. So we are still in the first maths question. Hope you are getting great information from this. So let's get straight into it. Now, if you downloaded the question, you will see that from question 4a, we're doing question 4a. Very quick so that we can shorten everything. Question 4a. A box has length of what? And I've told that when it comes to such questions, one of the easiest way to do this is to do what? Is to write down the parameters you have. Once you write down the parameters, what are the importance of that? It tells you what you have. And once you know what you have, then what the question looking for, you can solve it for them. So it's very important to write down the data out of the question. So let's use that approach to see if we can solve this. A box has a length 8 centimeters, width 5 centimeters, and height 10 cm. A box has a length. So I'll write it down. Length equals 8 cm. The length of the box equals 8 cm. The width or the width equals 5 cm. Then the height is giving us 10 cm. So I have them. These are the information I have there. Now, question says I should find the total surface area of the box. I should find the total surface area of the box. To find the total surface area of the box, I want to demonstrate using this box so that you understand how to get the total surface area of a box. Now, this is a very nice box. I want to calculate the total surface area. The question is, how many surfaces do I have here? How many surfaces do I have? If you could see this, let's count the number of surfaces I have. Surface 1, 2, 3, 4, 5, and what? And 6. I'm going to label it to make it easy. So I label this surface 1, then I label that surface 2, I label this surface 3, I label this surface 4, I give this surface 5, then I give that surface what? Surface 6. So I have 6 surfaces. And I'm to find the total surface area. To find the total surface area, I'm going to add up the area of each of the faces. Then I know the total surface area. So we are going to do this together. When I show you the surface, then we look at the dimensions of that surface and write it down. But before, if I'm looking at this, this is my length. The distance from here to here is my length. The distance from here to there is my height. And the distance from there to there is my what? My breadth or my width. So this is the dimensions. So this is the height. That is also the height. That is length. That is height. That is breadth. That is what? That is height. So we have this. The same will happen here. When I show here, this is my length. Then this is my breadth. Show this is my height and that's my breadth. Good. Let's go straight into it. So to find the total surface area, that's right. Total surface area of the box. So let's go. Total surface area of the box equals, the box has how many faces? 6 faces. Now we're going to calculate the surface area of each of the faces, then we add them. So let's go. We'll have face 1, face 2, face 3, face 4, face 5, and face what? Face 6. Now let's look at this. Let's look for face 1 and write down the dimension. Calculate the area for face 1. So for face 1, what dimensions do we have? For face 1, we have the length times the what? Times the height. So write down the area, the formula down. Area is what? Length times height. That is for this. Then plus, let's look for face 2. For face 2, we have the breadth or the what? The height. The breadth or the width and the what? And the height. So we are going to multiply the breadth times the what? Times the height. Then look for face 3. These are face 3. And we have what? Length with what? With height. So plus the length times the what? Height. Then we look for face 4. And that's our face 4. That is our breadth and our what? Our height. So once again, breadth times height. Then for face 5, what do we have? This is our face 5. So for face 5, we have this side. So this will be our, once again, you should know, this will be our, let's check it properly. This is our length. This is our breadth. So this will be the length and the what? And the breadth. Okay, so this will be the breadth. It goes here like that. So that's the height. So length and breadth. Let's show it. So that will give us our length Let's put this L, the length, and the what? Breadth. So these are length times the what? The breadth. And the same will happen to field 6. These are length. Of course, we've labeled that already. Our length and our what? And our breadth. So that gives us once again length times what? Breadth. Good. Good. So now let's go. Now let's simplify this. We'll have this is my formula work. I'm doing this practically for you to get this. You can also get the box and label it and see if you are going to get what we have there. So let's go. Let's get into this. Now, length times that will give me LH, then plus BH, then plus LH, plus BH, plus LB, plus another one, LB. So these are the surface areas. Now let me look for like terms. This guy is with that. So I get 2 times of the what? Of the LH plus 2 times of the BH, 2 times of the BH, then plus 2 times of the what? Of the LB. And from factorization, since 2 appears here, there, and there, I'm going to factorize 2 out. When I factorize 2 out, I'll get LH plus BH plus LB. So we have this. Now that we have this, we have simplified the formula. Now we have listed the dimensions here. All we have to do is to substitute. Substitution, one of the most important topics you need to be acquainted with. So let's go. Let's do a substitution. This gives me what? This gives me 2. Let me use a square bracket. So for the first one, what's my length? My length is 8 times my breadth, times my height, which is what? My height, which is 10. So I have this. Then plus my breadth once again is 5 times the height, which is what? 10. Then plus, what's my length? My length is what? Is 8 times my width, which is what? Which is 5. So I use the square brackets. Good. So this gives me 2. Then into bracket, what is 8 by 10? 8 10 is what? 80 plus, that's 50. Then plus 5, 8 is what? Is 40. So I have this. I'm going to get 2 into bracket 80 plus 90. 80 plus 90. So this is what I have here. 80 plus what? 90. Then I multiply, I'll get what? I add them, I'll get 2 into bracket. 80 plus 90 gives me 170. Once I have 170, multiply 2 by 170. I want us to do it somewhere here. 2 by 170. Let's do it here. 170 times 2. I know why we are doing this. 170 times 2. 2 times 0 is what? 0. 2, 7, 14. So I pick 4, remainder 1. You can see alongside. Now, remainder 1. 2, 1, 2. Plus the 1 gives us what? This is 3. So we have 340. So this gives us what? 340. And we are looking at surface area. So 340 centimeters square. So this will be the surface area for the box. You got it. This is very simple. Hope you got this. Yeah. So therefore, the surface area for the box is what? Is 340 cm square. That's the surface area. Good. And that is about the question 1. Very simple. Very simple. If you want to understand better, after this, take more questions under this and solve them. Once you solve them, you're able to solve more when you get them. Very, very simple. So this is how we solve question 4a. Let's go to question 4ai. So this is question 4ai. 4ai. We are going to question 4aii. Question 4aii. You can pause the video, right? Solve it later and compare. Okay, now question 4aii. Question 4aii. Numbering of your question is very, 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 very important, very key. So that the person marking can know which question number and give you your marks. Now, we have volume of the box. And we know volume, like I said earlier on, in the other question, of volume is mostly the base area. The base area times what? Times height. Volume is mostly the base area times height. Now, if we come to this, our box here, this is our base area. So we multiply this by what? The height. The question is, how do we get the base area? The area of the base is our length times what? Our breadth. So in this, to get the volume here, It is the base area, which is a rectangle for this. So it is length times breadth times obviously height. Now we already have this. Yes, we wrote down the parameters, so we just substitute them. What length are we giving? We're giving a length of 8 cm times the breadth of what? 5 cm times a height of what? 10 cm. And we multiply this and give them their what? Their volume. 5 by 8 gives me 5 8 is 40 times 10, and that gives me 400 cm cube. Then with volume, so that since we multiply 3 dimensions in order to get the answer, then we have cube. In the area, we have square because we multiply only what? Only 2 dimensions. Only 2 dimensions. Good. So this is what we have. Therefore, the volume of the box is 400 cm cube. Very, very important. So this is how we do question 4B, question 4AII. Go straight away into question 4BI. Question 4B is about graph. And I like graph work so much. Good. I like graph work so much. And when it comes to graph, one thing you should know is how to scale your graph. You understand your graph paper or your graph sheet. You understand your graph sheet and you know how to work with it. Now, in the graph sheet or your graph sheet, we have 2 centimeters from this length to that length. Between this is 2 centimeters. Between that is 2 centimeters, 2 centimeters, 2 centimeters. That is 2 centimeters. So anytime you buy a graph book, check and see from the shopkeeper that is it 2 centimeters or 1.9. I don't have 1.9. That can also count if you have 12 here against 10. Then you get a standard graph. 12, I mean 12 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 here, then 12 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. When you have 10 against 12, then you have a standard graph with 2 centimeters. And I said the next thing you have to understand when it comes to graph is what? Is the scaling. If you are told to use a scale of 2 centimeters to 1 unit, what this means is that after every 2 centimeters, keep adding what? 1. So if I start from 0, every 2 centimeters, I add 1. So 0, 1, 2, 3, 4. Every 2 centimeters, I add what? I add that. Now, when I'm told to do 2 centimeters to 2 units, what that also means is that to 2 units, what it means is that after every 2 cm, I give what? I move 2. I add 2. I keep adding what? 2. So if it's that gives I start from 0, that gives me 2, 4, 6, 8. So this is 2 centimeters to what? 2 units. And that is 2 centimeters to what? 1 unit. So that is basically how we do our scaling. Very, very important for you to know that. Very, very important for you to know your scaling. Good. So let's continue. So now that we have a little bit of the scaling, let's go into the question and see. I say so. B, are you seeing a scale of 2 centimeters to 1 unit on both axes? Draw 2 perpendicular axes, OX and what? OY on a graph sheet. So as our graph sheet, let's go and draw. And one thing you should know, the axis, most of you think the axis must always be in the middle. No. The axes are not static. The axis can move, or they move depending on the values you have. If you need more positive, then you are going to move to what? To a side that gives you more positive. If you move more negative, you move. So they are movable. You can move them in order for you to get the values you have there to plot. So don't have it in memory. Don't keep it in memory that you have to make sure it's always in the middle. No. Now for this transformation, we can draw it in the middle because we'll be able to plot what we have there. So in this, we have 10 here. So I'll put on the fifth box. We have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I look for the fifth one and I draw it in there. So 1, 2, 3, 4, 5. So I draw it on the fifth line. Now, when you want to draw these things, make sure you know how to use your pencil and your ruler. I always tell them that make sure the tip of the pencil is here. The tip of the pencil should be here. When you move the ruler to it, you check and make sure the same thing is there. You do this well. When you are doing construction, you have to take your time and do this. You have to take your time and do this. So let's go through. Draw a line perfectly through this. Perfectly through this. Good. Then here too, we count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So we put it in the middle. 1, 2, 3, 4, 5, 6. Okay, so put it here. Let's put it here. Let's put it here. And make sure we have everything intact. Once we have that, let's put this one a little. Okay. So now we go this way. Nicely draw our axis. Remember, it's a question number with demands marks. So we do it properly. We do it properly so that we can get the marks there. Marks be awarded for this. After drawing this, the next thing to do, not to forget, is to label your axis. So I'll label this as my y axis, and that as my what? As my x axis. Very important. Anytime you finish drawing, make sure you have what? You have labeled your axis. Very, very important. Anytime you draw the axis, make sure you have labeled them. Good. So let's continue. Now, using a scale of 2 centimeters to 1 unit on both axes, people draw two perpendicular axes, OX and OY, on the graph sheet. Draw two perpendicular axes. So I have my OX and my what? My OY on the graph sheet. So I've answered question 4BI. That will mark for me. Now, on the same graph sheet, mark the axis or the x-axis from -5 to what? +5. Mark the x-axis from -5 to +5. So for the x-axis, I have 0 here. The positives will be on this side and the negative on that side. So using a scale of 2 centimeters to what? To 1 unit. 2 centimeters to 1 unit. So we'll have 1, 2, 3, 4, and what? And 5. And this one gives me -1, -2, -3, -4, negative what? 5. And this one gives me, so here we are going 6. This one gives me 1, 2, 3, 4. See this. So that means the axis we do here is supposed to be here. So we can get our 6, 0, 1, 2, 3, 4, 5, 6. Good. So that means we have to move this axis down. Good. This is very good for me so that you know. The next time you're drawing, you know how to put that so that you get it there. It will not affect the work, but for the sake of accuracy, I'll move once down so that I get my correct drawing. So I'll move here. Let's take our time and do this. Let's take our time. So from here, good. So that is 0, -1, -2, -3, -4, -5, and negative what? 6. Good. So this one gives us 1, 2, 3, 4, 5, 6. Then this one gives me 1, 2, 3, 4, 5. And this one gives me 1, 2, -1, -2, -3, -4, -what? 5. And if that's so that we get a -6 to what? To +6, so we can get that marks that is giving there. We can get a mark. So make sure you have done or you listen to what? Instruction. That is also part of the work of the exam. Okay. Now we have drawn the axis. We've labeled it. Now let's plot the points A. So now we have plotted the points A. Now anytime you are plotting a point in math has an x coordinate and what? And a y coordinate. So in math, when we see a point has x and what? And y. So this is always on our x axis, and that is always on our y axis. And math mostly is done in 2 dimensions. And to plot the point is very important. Anything I'm plotting a point, I have demonstrated your first point is your x, and your second point is your y. So the first number is your x, and the second number is your y. So let's plot the first one. So we're giving the first one as well as A0, A was 0, 3. So for point A, we have 0, 3. Now 0, 3 means that we look for 0 on the x-axis. This 0 on the x-axis, then 3 on the what? On the y. So 0 came first, 0 on the x, 3 on the y. And now this is how I take it. There's no x. So it's just for the y. So I'll put this one here. And one thing I need to remind you of, when it comes to putting the points there, those days where we do kind of this, we shade, it's gone. We don't do this again. Now you can either put a 9 stroke at that point so your lines can go through, especially linear graphs. Or some people prefer to just put a nice point around it and draw through and just make their point. and draw through. Good. So we have this and draw through this. But I prefer to use this. You can do this, but I prefer to use that. I can get the point of intersection. But anyone doing this should avoid that. Should avoid this. You don't get the point clearly. And if it's linear graph, most of the time you get wrong because when you're reading from the graph, you get what? Wrong reading. So I have this, and A gives me what? 0, 3. Always label your what? Your axis. Very, very, very important. Then B we have 2, 3. So B is 2, 3. Like I said, look for 2 on the X, then 3 on the Y. Is 2, 3. And that is B. Then I put 2 what? 2, 3. Good. Good. Then I take C. C is what? 4, 5. C is 4, 5. I look for 4 on my X, then 5 on my Y. And there is it. That is it. So C, I have 4. I have 4, 5. Very well done. Then I join them to form what? To form the triangle ABC. I join this to form triangle ABC. So let's join this to give our triangle. Let's join this. Yeah. And I hope you are doing this with me. If you don't have a graph sheet, then I plead with you to get a graph sheet and do this alongside as I do this. If you don't have a graph sheet, then you pause the video, then you go get a graph sheet and follow. Mark is our practical. Don't think you will get it. Yes, you might see it, you might understand it. But at the end of the day, if you don't practice with me, if you don't become a participant as I'm doing this, then you find it difficult the next time to do it. So I beg you, if you don't have your graph, pause your graph. Now let's do it alongside. Thank you very much. I hope you have done that. So now we are all on this level. We are all here. Let's continue. If you've not done that, pause and do it so that we can continue. Get yourself involved in the work, in our lesson. Very, very important. The aim here is to make sure you get your grade 1, to get yourself involved. Okay. Now, 4BI, 4BIV, 4BIV. It says that draw the image A1, B1, C1 of triangle ABC under the reflection. Now what we are doing here is transformation of what? Of 2D shapes. And in transformation, there are ways that which you can transform. You can transform an image by rotation, by reflection, by translation, by enlargement, and also by what? By special mappings. Transformations means that we are changing the shape and size of the object. We are changing the position and size of what? The object. We can't take the shape. It's a triangle, it's still a triangle. But we change its what? Its size and what? Position. You can enlarge, you can back the position also. That's transformation. And we do that by the points I just mentioned. Here we have translation by what? A vector. So I'll have to get 4. Question number 4BIV. 4BIV. And it's translation by vector. The vector given was -1, -1. Now, anytime you are translating by a vector, people means you add the vector to your point. So if I have my point is xy. If my point is xy per this, then I'm going to add my translation vector to this as -1, -1, and that gives me adding this, applying vectors. Then I'll get x minus 1, then y minus what? 1. So this is what I'm going to do. I'm going to add each of the points given to me. If you are translating, it's just addition of the points to the what? To the coordinate or the vector given. Good. So let's go. Now let's transform. We are transforming the triangle ABC. We are transforming this triangle using translation. So we take our first point, which is point A. Now, for point A, we have 0, 3. Point A is 0, 3. So we translate 0, 3 by adding our vector, and we have -1, -1. When we do this, we are going to get A1 to give us what? To give us x, which is 0 minus 1. Then 3 minus what? 1. And this will give me A. The coordinate becomes on -1, and we subtract 2 and get what? 2. Be careful with your unit. But that is to get what? 2. So this is what we are going to plot. Then we have B. And B, the point B was what? It's 2, 3. So B, we have 2, 3, plus, once again, the vector -1, -1. And that gives me B1. And what is B1 here? B1 is 2 minus what? 1. Then 3 minus what? 1. So B1 once again gives me what? This is 2 minus 1 gives me 1, and that gives me 2. So this is B1. This is what I'm going to plot. I'm going to plot this, then and this one. Good. Now let's go to C. C says that we should also work with what? 4, 5, I presume. It's 4, 5. Yeah, I got that. 4, 5 plus minus 1 minus 1. And this gives me C1. That is 4 minus 1. Then 5 minus what? Minus 1. Good. So let's go. So this gives me C1 as well as 3 and 4. 3 and 4. So let's go through. We have everything. 2 minus 1 is 1. 3 minus 1 is 2. 0 minus that is negative 1. Then this gives me 2. Good. So now we are going to plot this. Now let's plot this on the graph. Once again, I'm plotting this, that, and what? And that. Okay, so let's plot this. Let's plot this. What's A1? A1 is a negative 1. So I look for negative 1 on my x-axis. Then positive 2 on my y. So this is where they meet here. They meet here. So that gives me A1 minus 1 minus 1, 2. Then I have B1 is 1, 2. Okay, so B1, 2 is 1, 2. Here is B1, and that is 1, 2. Then I have C. C1 is what? Is 3 on the x-axis, then 4 on the y. So 3 here, then 4 here is lying comfortably here, comfortably there. So C1 equals what? 3, 4. Equals 3, 4. Then I join them to form my what? My image, my first image. So let's join this to get our first image. This gives me nicely done. I hope you are doing this with me. I hope you are doing this with me. Do this with me. Let's practice. Partake in what we're doing. So let's join this together. Now let's join this together. Good. So now we have our diagram nicely drawn here. Nicely drawn here. Good. So this is our diagram. It's a A1, B1, and what? C1. Lastly, we are supposed to reflect in what? In the triangle in the x-axis. Reflection is either done in the x or the what? The y-axis. Always note that in reflection, we apply the principle of what? Of light or mirror when it comes to this. Anytime I look into a mirror, I form an image. The image I form there is the same as what? My object. The distance between myself, which is the object, and the mirror is what? It's called the object distance. The moment I move closer, the image also moves closer. Why? Because the object distance, the distance between the object, myself, and the mirror is the same as the mirror and the image. That means anytime we reflect, we should get the same distances. With this understanding, I can reflect my object without using the formula. But I'm going to apply both of them here so that we see how it works. So for this, we go with reflection in the x-axis. Reflection in the x-axis. And anytime I do reflection in the x-axis, the y component is negated. You negate the y. Reflection in the x-axis means what? Negate the y. Reflection in the x-axis means that we are using the x-axis as our mirror line. And once we are looking into the x-axis, our mirror line, then our image will be formed here. And once the image is formed, it is laterally inverted. Look into a mirror and you will see that your right hand becomes what? Your left hand. That's a characteristic of an image formed by the plane mirror. Characteristic of an image formed by the plane mirror is that the image is what? Laterally inverted. That means the left becomes the right and the right becomes the what? The left. Okay. So that being said, let's go straight into this. So if you are reflecting a point xy, reflecting a point xy, I said xy, since we are reflecting this point in the x-axis, we maintain x and negate what? And negate y. We maintain x and negate 2 and negate y. So let's use this to solve our question. So A, let's go. We are transforming A, which is A is 0, 3. So we have 0, 3. And 0, 3 should give birth to A2, which is maintain 0 and negate what? 3. Maintain 0 and negate 3. Then we go to now have A2 to be 0 minus what? 3. Then we have B, which is 2, 3. And B2, 3. B2 will mark onto, we maintain 2 and negate what? We are following this general formula we have written down. Following that general formula. Then we take C, which is 4, 5. Then if we have 4, 5, what do we have here? What do we have here? We will have C2, and C2 gives us, we maintain 4, negative what? 5. And that gives us C2. Then we have 4, negative what? 5. We have this. Now we are going to plot these guys there. And as we are plotting, I'll show you how we can plot with this or we count. So listen to me and you can know how to do that. Either we count based on the principles of reflection or we use the formula. So anyone you use to get your answer. Let's go. So we are plotting 0, negative what? 3. 0, negative. That's 0 on the x and negative 3. So we have it here. So like I said, this is an object. These guys are object A, B, C. The distance from this to that, let's use the boxes. So this is the first box. So 1 box, 2 boxes, and what? 3 boxes. So 3 boxes with the mirror, which is the x-axis, means we should go 3 boxes down. So this is the first box, the second box, and the third box. And that makes sense. So our point is exactly at all at that point, at that place. Okay, let's go. Then B, we have what? B, we have 2 B2. We have 2 negative what? 3. So for 2 negative 3, let's go. 2 negative 3. I look for 2 on my x-axis. That is it. And negative 3 here. So this is how I should label the point. Very important. Let's label. So BA2 equals 0, negative what? 3. Then B2 equals 2 and negative what? Negative 3. Let's see if by counting we'll get that. The distance from this to a mirror, let's see, using the 2 centimeter box. So to point it on your notes, on your geometry, so you can get it pointed. Look at this, point with V. So 2, that is 2 centimeters, that's 1 box, 2 boxes, that's 3 boxes. So let's go. That is another 2. So that's 2 centimeters, 1 box, 2 boxes, that's 3 boxes. That makes sense. That means that what we are saying, or the laws of reflection work, they do work. Good. Let's try this one. So this one, let's count first of all. Then we go and apply this and see. So let's count. Let's count the distances from there. This is the first box. 1, 2, 3, 4, 5. That means we go 5 down. 1, 2, 3, 4, 5. Our point should be here, somewhere here. Okay, now let's go back and plot this and see if that point will still be there. We are plotting, well, x, which is 4, and y, negative 5. This is 4 and negative 5. See them? Good. That means this is exactly what we are looking for. So I can either count or use the formula. Which way is easier for you? You're okay. So let's go. So this gives me my C2, which is what? Which is 4, negative 5. Then I join this to get my drawing. I join this to get my transformation. So let's go. So I join this. Then I join this to this. Let's draw the point properly here. Good. I join this to that. Then I join this to this, and I have this thing wonderfully done. Then I have this thing wonderfully done. All the points labeled. Then this is my graph. This is my graph. So this is how we are going to plot this. And I hope you have the same thing that I have. If your diagram is looking different from this, then you have to begin and look at the steps we went through in order to get this. So pause the video, get your graph, and do this. At the end of the day, we have this nice one. Thank you very much for joining the class once again. We shall meet again in the next class. Remember to subscribe and tell your friends to watch this. Watch this one. Will bring you more interesting questions to solve, so that at the end of the day, our agenda will be fulfilled. Thank you very, very